Hi everybody, welcome back to another video on Feynman integration. Today we're going to be evaluating this integral, which is the integral from 0 to infinity of cosine of ax minus cosine of bx over x squared dx. I rewrote the Leibniz integral rule because I realized it was a little small in my last video. And I just made a little note right here that this whole thing right here, this part of it will evaluate to 0 if the bounds of integration are constants. Because if you take the derivative with respect to t of a constant, you will get 0. Same with right there. So all you'd be left with is the special case of the Leibniz integral rule, which involves constants of integration. Anyway, here we go. So the first thing that we're going to do, like always, is create a function of t equal to the integral from 0 to infinity of cosine of tx minus cosine bx over x squared dx. I realized that I could have just right off the bat called this a function of a, or technically I could have called it a function of b as well. But I like to keep things consistent. So, because right here, technically A and B are what are called arbitrary constants. They're not variables. So we're creating a function of x and t right here where B is an arbitrary constant. And we will note two things, that if we evaluate our function at the point t is equal to a, in other words, if we plug in a for t right there, we'll get I. And if we plug in the point t is equal, if we plug in t is equal to b into our function, we'll get cosine of bx minus cosine of bx, which is 0. So the whole thing will evaluate to 0. As always, we're going to take a derivative with respect to t on both sides. And what that will give us, using the special case of the Leibniz integral rule for constant bounds of integration, is going to give us f prime of t is equal to negative integral 0 to infinity of sine of tx over x dx. And if you've watched my previous videos, I believe there's 2 examples of this going to negative pi over 2. Yeah, so f prime of t is equal to negative pi over 2. Watch my other videos if you want to see that. I believe I solved it 2 different ways. So we have f prime of t, and of course we're not interested in f prime of t, we want f of t. So we integrate f prime of t, and we integrate negative pi over 2 with respect to t. That will give us f of t being equal to negative pi over 2 times times t plus some constant of integration. If we plug in the fact that f at the point t is equal to b, we get 0. That'll leave us with 0 is equal to negative pi over 2 times b plus c, giving us c being equal to pi over 2 times b. Plugging that into this equation up here, if we plug pi over 2 times b in for this c, what we'll end up getting is that f of t is equal to negative pi over 2 times t plus pi over 2 times b, which is equal to pi over 2 times the quantity b minus t. And then if we use this fact right here, that f evaluated at the point t is equal to a, we get I. That just gives us our final answer for this video, which is I is equal to pi over 2 times the quantity b minus a. So that whole thing evaluates to this with certain restrictions, of course. But anyway, that's the answer. Hope you enjoyed that.